So I'm actually a college athlete who is also in the Army. So I'm pretty busy. I wake up at 4:30 every single morning, and then I go to class and I have workouts and softball practice and whatnot. But you have to be very diligent. You have to, whenever you have free time, that's when you do your homework. After practice, if you're a student athlete, that's when you study. You have to be very on top of things and you cannot procrastinate if you want to be successful.
Hi guys, my name is Kaylyn Chapman. Today we will be going over advanced calculations of pH. In this video, we will be discussing the different ways of calculating the pH of a solution. In previous videos, you learned about pH along with weak and strong acids and bases. To review, pH is the measurement of the hydrogen ion concentration. It is a scale that ranges from 0 to 14, 0 to 6 being acidic, 7 being neutral, and 8 to 14 being basic. Using that knowledge, we can now discuss how to calculate pH in each scenario. Steps to calculating pH. The first step is to identify the acid or base conjugate pairs and determine if it's a strong or weak acid or base. The second step is to balance a chemical equation. The third step is to make an ice table if necessary. The fourth step is to plug numbers into proper equations and solve. And the fifth step is to review calculations. In this slide, you will see the equations that are used to solve for pH. We will first go over the three main equations. The first one is pH equals the negative log of the concentration of H+. The next equation is the Henderson-Hasselbalch equation, which is pH equals pKa plus log of base over acid. The last one is pH plus pOH equals 14. Now sometimes we don't always have the variables that we need for these three equations, so the next equations we're going to talk about are ones that we can solve for the variables. So we have pOH equals the negative log of OH minus, Kb equals Kw over Ka, pKa plus pKb equals 14, and pKa equals the negative log of Ka. In this slide, you can visually see what equations you can use for acids or bases that are weak or strong. For weak and strong acids, you can use pH equals negative log of H+. For weak acids, you can also use the Henderson-Hasselbalch equation. For weak and strong bases, you can use the equation that is pH plus pOH equals 14. But for weak bases, you can also use the Henderson-Hasselbalch equation. The first example problem that we will go over is what is the pH of 0.05 solution of potassium hydroxide? So we know that KOH is a strong base. This strong base will completely dissociate in water to be K plus and OH minus. So that means for every 1 mole of KOH, there will be 1 mole of OH minus. Therefore, the concentration of OH minus is 0.05. Since we know the concentration of OH minus, we can use that to calculate pOH and solve for the pH. The equation to find pOH from OH is pOH equals the negative log of OH minus. Using that equation, we get pOH to equal 1.3. Now we will use the equation pH plus pOH equals 14. That gives us a pH of 12.7. The next problem is calculate the pH of a 0.10 solution given that the Ka is 6.8 times 10 to the negative 4. Before we begin, we can determine that HF is a weak acid. We will first start this problem by setting up the balanced chemical equation. That will be HF yields H plus F minus. Now that we have the equation, we will set up our ice table. To get the concentration of H+, we will have to use the Ka to solve for X in this ice table. To solve for x, we'll use the equation Ka equals the concentration of products over the concentration of reactants. So with the numbers plugged in, it'll look like 6.8 times 10 to the negative 4 equals x squared over 0.10 minus x. We will now multiply 0.10 but on both sides, and we are left with 0.000068 equals x squared. To get rid of the x squared, we will take the square root of that number. So then we are left with x equaling 8.2 times 10 to the negative 3. We solved for x, but that's not the end of the problem. We will now plug x into the ice table to get the concentration of H+. We see that the concentration of H+ is now 8.2 times 10 to the negative 3. To get the pH of the solution, we just have to use the equation pH equals the negative log of H+. Using that equation, we get pH to equal 2.1. The last problem is find the pH of a buffer that consists of 0.24 NH3 and 0.15 NH4+, and it gives us a pKb of 4.75. For this problem, we'll be calculating the pH using the Henderson-Hasselbalch equation. Since we already are given the concentration of the acid and base, we do not need to solve for x using an ice table. NH3 is the base with a concentration of 0.25, and NH4+ is the acid with a concentration of 0.15. Since we are using the Henderson-Hasselbalch equation, we now need to get the pKa. If you remember, we can get the pKa from pKb using the equation pKa plus pKb equals 14. So that gives us pKa being 9.25. Now we will plug all the information that we have into the Henderson-Hasselbalch equation. That gives us pH equals 9.25 plus the log of 0.25 over 0.15. So now the pH is calculated to be 9.48. That concludes our video on the advanced calculations of pH. If you have any questions about acids or bases, go ahead and check out our other videos. Bye guys, hope that helps.